probably sitting there wondering what is a land surveyor who typically sells airborne systems going to present a topic on indoor mobile mapping. Well, I'm trying to figure it out too, but we'll just go with it. So this is what I'm really going to try and talk to you about today. I'm going to talk about Trimble's involvement in the development of this technology, really from a Trimble sense. It's not going to be a sales pitch. You're going to see Trimble and you're going to see different stuff, but it's really trying to make it an information session. So, but I'm going to use the examples from Trimble because, you know, in Planix we've been doing the inertial navigation systems with it. So just really look for the information in this and pay a little bit of attention to the Trimble banner. Okay, so what I'm going to try and talk about very quickly here is how we map inside buildings when you lose GPS, GNSS signals. Okay? So before we begin, I thought I'd take a quick run through. There are some of you in the room that are quite familiar with inertial systems. Some of you perhaps are not. So I thought I'd just take a quick couple of seconds and just review again from the Planix standpoint, developing these integrated inertial systems over the years and why they're used. And the reason for that is if you just use GPS, it has some, it's pretty good accuracy, but it has its limitations that, you know, you can't take it indoors, you have canopies and that kind of thing. With inertial, with IMUs, you have a full measurement system. It's self-contained, but it loses its accuracy very quickly. So what Planix did 15, 20 years ago, they developed a way where they could use inertial IMUs to basically calibrate GPS signals. And the blend of the two technologies is what allows us to do most of the things that we do today in airborne mapping and land mapping and LiDAR systems and mobile mapping and stuff like that. Integrating the technologies, again, you know, by the time you take GPS and GNSS and merge it with an inertial navigation system, you end up with a full navigation solution, position, orientation, and velocity and acceleration. So you have all of that. And there really aren't too many limitations to it, truth be told. It is state of the art. It is what you need to have in order to do the mapping that you need to do in dynamic mobile environments. So just to give you an example on the land side using land vehicles, it's, you know, we use the inertially aided navigation systems. So the system is comprised of the IMU itself, integrated GNSS receivers. For land vehicles, you put what's called a DMI, a distance measuring indicator, on the wheels to aid in the measurement as well. And we use an extra GPS receiver. It's called GAMS, but it stands for GPS Azimuth Measurement System. So just to help improve the heading a little bit as you're traveling. So now we just covered that little introduction on inertial systems and GPS. We take the whole thing and let's move it indoors. And I'm sorry, Jim, it's not when you're standing. So, but basically, you know, if you want to map the inside of a building, typically you had, up until recently, two ways of doing it. You do it the way I did it when I was in practice. I measured two buildings, 24 floors each, downtown Toronto. I had a guy with me and a steel tape, and I took notes. And I measured the whole building, every floor. It took me almost 3 weeks to do it. More recently, you can take a static LiDAR scanner, take it inside, throw it up on a point, and you've all, most people have seen, scan the room and away you go. Now what's happening with the introduction of inertial GPS systems, we can take those LiDAR scanners, static scanners, put them into a cart-type snare that we have down here in the bottom, add a video camera to it, and basically move the system through the room, the building, whatever, and you're scanning and recording video data, camera data, and you're also recording the inertial GPS because the inertial system allows you to work inside with GPS outages. So why do we do it? Well, there's productivity issues. I mean, it's a rapid acquisition. Instead of setting up static scanners and periodic spots, you can just move the card around and away you go. It gives you very rapid visualization and rapid exploitation of the data as well. You can generate two-dimensional, three-dimensional models using this data. It allows you to go in and out of all the different parts in a building or a room. And you can capture the data very quickly. I mean, with a cart type system, you can do 100,000 square feet a day without too much trouble at all. Just a little comparison to traditional methods. You'll see Tim's, and I'll talk about that in a second, but you can see the detail that you get just by running the scanner around the room as compared to if you're using a handheld. You know, a lot of people have been mapping inside a building with a handheld distance measuring thing. You get the same accuracy, but you get so much more covered and so much less time. So the example that I'm going to talk a little bit about today is the Triple Indoor Mobile Mapping System. We call it affectionately TIMS. And this is what it is. It's been in development with Planix, about 3 years, I guess. 3 years. Started out not looking quite that nicely, but it's developed to this state, and the whole system has a laser scanner, camera, the integrated inertial system, GPS, power, and an operator's console, and the workflow is also included in the whole system. Now you can see here on the left is an example of if you're trying to map the floor of this building. The red spots on the left would be typically where you have to set up your static LiDAR scanner. Okay, 1, 2, 3, 4, about 12 of them. With a mobile cart using inertial systems, you can actually push the cart, and it travels at it'll collect up to about 1 meter a second. So you push the cart at a good walking speed. So you just walk it in and out of the rooms, and it's scanning the whole time, and you close it back off, and you're basically done. So it's that next step in kind of efficiency to just doing static scanners. I mean, if you're just going to do one room, bring a static scanner and away you go. But if you're going to do a whole building or a whole floor, this is a little bit more effective to do it this way. So what's a value proposition? Well, I don't even probably have to tell you just by looking at it. You don't need to co-register scans. A lot of really good data content for this, the LiDAR and visual stuff as well. It's a complete hardware and software integration system, and you can, colorization, easy accessibility to the data as well. You can take up many floors in a building as you want. It's not elevation restricted. What will happen is you bring a little control point in on the main floor, and you can throw the cart in an elevator, go up and do each floor, and you can see on the right-hand side here, that's actually the superimposed trajectory of the cart as it did those 2 floors. And when you're done that, you come back down, you close in on your control point again, and done, you're at the door. So it kind of closes the loop. So it's not elevation restricted. Talk a little bit about some market segments. There's construction, obviously. I think a lot of you can see from this that it's certainly got a place in construction and pre-construction, as built, and all the rest of it. Space optimization. Clearly, if you have a mobile mapping system, you can go in and see what's in a particular space, and measure the space, and do whatever the requirement is. One of the big ones is this public safety, situational awareness, and rapid response type stuff. Security issues, for example, these types of systems are being used in airports now to go in and map the whole airport before VIPs come through, or if there's any kind of security question at all. We'll send something like that in. You can go in a day, map it, and get out, produce the data, and it's virtually done. So just a little bit about construction. With pre-construction, you can use these systems to analyze material flow and impact operations. It's cost effective. You can do 2D models, 3D models, as I mentioned before. You can use the base maps, coordination and scheduling contractors as well. During the construction, you can imagine that you can map the different stages of how the work is going, kind of like so you can track things while the construction is being built, and see it, what rate is being done, and go back and check it. Post-construction, you can obviously use the data for creating all sorts of different models that you like. It's QA/QC processes you can assess with it. Change detection is very easily done when you have the data. And there's one map, multiple uses type concept as well. So you have 2D and 3D as built data. We can introduce it or use software that's available on the web to look at the data, assess it, whatnot. There's a bit of an example of situational awareness. And I apologize for the how it comes out on the screen. It looks a lot better on mine, but that's basically Terminal 1 at Toronto Pearson International Airport. And you can see a certain section that was blown up here on the right. It's the security and customs area for those of you who travel through Toronto. But you can see the amount of data that's collected. Just the LiDAR point clouds here, but you can drape with the video camera, you can drape the imagery on it as well. But that took less than a day to go through and map that inside that terminal. And that's a pretty big terminal. It'll take you probably 15 minutes to walk from end to end. You can see some of the detail you can get. This is actually part of the Planex's main floor. But you can pick out the wall thicknesses and see the cubicles and all the rest of it. And you see the complexity of the way the cubicles and the whole floor is set up. The mobile mapping system can go in and very quickly just go in and out the hallways and map it all and produce that very, very quickly. Just another example of how you can go from one floor, you go to the next floor, point clouds, and you can see here down the right-hand side staircase and what's in there and what isn't and who's hiding in there and that kind of thing if you need to. So what do we deliver with this kind of data? What are the deliverables? Well, like I mentioned before, 2D point clouds, 360-degree imagery from the video camera that's integrated with the system. You can view it all on a web-based software. You can produce these 2D floor plans from the data that can be used for construction or assessment or demo projects. 3D models as well, easily generated from them. So this is kind of a cool shot, colorized 3D point clouds. This is actually main floor at Planex. I know it doesn't show up very well, but the detail that's in this that you can get out of these mobile mapping systems indoors, it's amazing. You go down, my office is on the second floor, so you can't pick me up in there too bad. But there are other places in there that it can show you the detail there, the depths and people sitting there and everything else. It's really quite amazing. So visually, it presents a product that never really, up until these indoor mobile mapping systems came along, we never really generated anything this kind of quality or detail before. Just a little bit, the software, the data generated from our system will run in Esri, Revit, AutoCAD, and Trimble's own software. Just to give you a little bit of an example of how this type of data collection system can work. In Toronto, we have it's called the Don Jail. It's an old building, goes back to the very beginning of the century, but as a matter of fact, I think it's the last place where we had gallows in Canada, and I think the last capital punishment execution in Canada was actually in the Don Jail. And they came to Planex because they wanted to it's a historic site, so they wanted to just go in and see what's in there and refurbish and everything else. So they wanted to go into a mapping process and then take that design and fix it up. So you can see here, and I'll just run through these quickly. You can see the image that was taken with the system on the floor there, and then up above is just a LiDAR point cloud that was generated. And you can see, all this stuff being indoors without GPS signal or anything else. It's